লাস্ট হ্যাশট্যাগ কবে ছিল জানি? লাস্ট হ্যাশট্যাগ ওয়াজ 12। আচ্ছা, সো 13। আচ্ছা, as far as I remember, যখন আমি 220 করছিলাম, there was this playlist by an Indian guy যারটা আমি অনেক ক্লোজলি ফলো করতাম। ইয়ে, কুনাল। আচ্ছা, ও করছে জাভায়। আই ওয়ান্ট টু কমপ্লিটলি ডিচ জাভা, কারণ খুবই একটা, কি বলবো, ব্লোটেড একটা ল্যাঙ্গুয়েজ আর কি। ইটস গুড ফর ফাউন্ডেশনস এন্ড বেসিক্স, বাট ফর নাও আই জাস্ট ওয়ান্ট টু ফোকাস অন পাইথন। সো আই ডোন্ট থিঙ্ক দিস, মানে থিওরি পার্টটা এটার জন্য ইনাফ হবে, বাট আই থিঙ্ক better to search for another language. Oh, plus another thing is that আমি পাইথনে নতুন, আমিও নতুন করে পাইথন শিখতেছি। My first language was Java. So আমি ওই কোড উইথ মশের একটা প্লেলিস্ট দেখছিলাম, ছোট একটা প্লেলিস্ট, এখান থেকে মোস্ট অফ দ্য বেসিক স্টাফ অফ পাইথন আমি দেখে নিছি। But still there are a lot of things to be learned, and you'll see me every now and then using AI to ask every other stupid question, small stuff. So yeah, pardon my ignorance. But yeah, let's start with Python. Data structures. Python. আচ্ছা, ফার্স্টে কি ওওপি করা উচিত পাইথনে নাকি ডেটা স্ট্রাকচারস? আই থিঙ্ক আইল বি ফাইন উইথ ডেটা স্ট্রাকচার শুরুর দিকে। Which playlist do I start? Oh, this is a very cool channel, Harvarder, full course for beginners. এই প্লেলিস্ট দেখে আমি 221 পাস করছি। নট রিয়েলি, বা অ্যাকচুয়ালি মুনতাসির স্যারেরটা দেখে আমি পাস করছি। But this playlist was also very cool for simulations and whatnot. Python data structures. So this 12 hour যে ভিডিওটা একটু খুলে রাখি। আমি ইউজুয়ালি যখন দেখছি 12 আওয়ার এই চ্যানেলের যে ফ্রি কোড ক্যাম্পের ভিডিওস গুলো মোস্টলি ফোকাসেস অন সারফেস লেভেল আর কি, থিওরি পার্টস।
Hey guys, Greg here.
আপনি কি কোড দেখেন? I need them to solve a problem after teaching the theory. হুম। আমার মনে হয় সাউন্ড শোনা যায় না স্ক্রিনের। এখন শোনা যাওয়ার কথা।
Cards has a number below it, and the numbers are in decreasing order. She challenges Bob to pick out the card containing a given number. For example, she could say, Bob, I want you to pick out the number 7 by turning over as few cards as possible. So this is a puzzle that's given to us, and we're not told how many cards Alice has, so you need to write a function to help Bob locate the card. So Alice can put down any number of cards, and the target number that Bob has to pick out could be anything. So we have to tell Bob not number the cards in decreasing order and lays them out.
Alice has some cards with numbers written on she arranges the cards in decreasing order. Alice has some cards with numbers written on she arranges the cards in decreasing and lays them out face down in a sequence on the table. She challenges Bob to pick out the card containing a given number by turning over as few cards as possible. Write a function to help Bob locate the card. She arranges the cards in decreasing order. So descending order basically. বড় থেকে ছোট পর্যন্ত যেতেছে and this is not face on same definitely. নাম্বার দিয়ে রাখছে এই নাম্বারটা যত কম টার্ন ওভার করলে পাওয়া যায়।
Face down in a sequence on a table. So this is what it looks like. These are cards. Each of these cards has a number below it, and the numbers are in decreasing order. She challenges Bob to pick out the card containing a given number. For example, she could say, Bob, I want you to pick out the number 7 by turning over as few cards as possible. So this is a puzzle that's given to us, and we're not told how many cards Alice has, so you need to write a function to help Bob locate the card. So Alice can put down any number of cards, and the target number that Bob has to pick out could be anything. So we have to tell Bob not the solution for a specific problem, but a general strategy that he can use to turn over as few cards as possible. So for instance, look at these 7 cards and maybe put some imaginary numbers below them, and try to figure out a strategy. Try to start thinking about the problem. And this may seem like a simple problem, especially if you're familiar with the concept of binary search, but the strategy and technique that we're learning here will be widely applicable, and we will soon use it to solve harder problems. Now, while you think about the problem and before we start solving it, I just want to talk about why you should learn data structures and algorithms. And whether you're pursuing a career in software development or data science, it's almost certain that you will be asked programming problems like reversing a linked list or balancing a binary tree in a technical interview or coding assessment. Now, it's well known that you never face these problems in your job as a software developer, so it's okay to wonder why such problems are asked in interviews. And they're asked because they demonstrate the following traits, and these are very important traits for a programmer. Number one is that you can think about a problem systematically and then solve it systematically step by step too. And the number two is that you can envision the different inputs and outputs and edge cases for your problem. Because programs, when you put them out in the wild as part of software, can encounter any kind of inputs. And as you have thousands or millions of users, you will encounter any and every possible input. And often this has many security implications. It can take down the server, it can take down your application, or you can have a loss of data or loss of property. You can communicate your ideas clearly to coworkers. That's a very important part of problem solving. And most importantly, you can convert your thoughts and ideas into working code. And the code should also be readable to other people. So it's not really the knowledge of specific data structures or algorithms that's tested in an interview, but it is your approach towards the problem. So you may fail to solve the problem, but you may still clear the interview, or vice versa. You may solve the problem and still not clear the interview. So in this course, we will focus on the skills to both solve the problem and to clear interviews successfully. So that's why you need to learn data structures and algorithms. So coming back to the problem at hand, now you've read the problem and you may have been thinking about it, and maybe you have some ideas on how to solve it, and your first instinct might be to just start writing the code for it. But that is not the optimal strategy, and you may actually end up spending a longer time to solve the problem due to coding errors, or you may not be able to solve the problem at all. So, what we are going to cover here is a systematic strategy that you should apply in interviews or in coding problems, or in coding assessments, or in general whenever you're faced with a problem like this. So, here's the strategy that we will apply. Step one, state the problem clearly, identify the input and output formats. Step two, come up with some example inputs and outputs and try to cover all the edge cases. Step three, come up with a correct solution for the problem. It can be as simple as possible and state it in plain English. Step four, and this is a step that is optional sometimes, implement the solution and test it using example inputs, and then fix any bugs in your first solution. In step 5, analyze the algorithm's complexity and identify any inefficiencies. And finally, step 6, apply the right technique to overcome the inefficiency, and then go back to step 3, which is come up with a new correct solution which is also efficient, then implement the solution and analyze the algorithm's complexity. So this is the technique that we will apply over and over for the course of 6 weeks to many different problems. And applying the right technique is where the knowledge of common data structures and algorithms comes in handy. So this is the method we'll be using. So let's jump into the solution. Step 1, state the problem clearly. Now you will often encounter detailed word problems and coding challenges in interviews. They will go on for paragraphs and paragraphs. For instance, here we're talking about Alice having a deck of cards and then shuffling them, putting them out on a table, talking to Bob, etc., etc., etc. The first step is to state the problem clearly and precisely in abstract terms, because computers don't understand people, computers don't understand cards, computers understand numbers. So in this case, we can represent the sequence of cards as a list of numbers. So a list is a basic data structure in Python. And the turning over of a specific card is equivalent to the accessing of the value of the number at a certain position in the list. For instance, if we think of this set of cards being represented by this list, you can see here that this list is sorted in decreasing order. Then turning over a certain card is equivalent to accessing that specific element from the list. So turning over card number 2, or as we say in computer science, card number
Index.
1, because this is card number 0. And this is one thing that you might want to get into your head as well, that whenever you're counting, always start counting from 0. Otherwise, you may run into many off by 1 errors. So this is position 0 and this is position 1. So if you turn over the card at position 1, it is as good as accessing an element from a given list, which in this case will turn out to be 11. So these are the positions in the list starting from 0. And now what we have to figure out is how many elements do we need to access. So we need to access the minimum number of elements to get to a particular element, right? So the problem can now be stated as follows. We need to write a program to find the position of a given number in a list arranged in decreasing order. We also need to minimize the number of times we access the elements from a list. So we're finding the position of the given number 7, and the position in this case is 3. And
we need to write a program to find the position, the index টা বের করব of a given number in a list of numbers are in decreasing order. আচ্ছা,
we want to minimize the number of times
সেটা কিভাবে করবো? আমার একটা কি থাকবে, আহ, কি হ্যাশ টেবিলও করা যাবে, হ্যাশ টেবিলের মতো, ওই যে কি ভ্যালুর মতো। So আমার যদি ভ্যালুটা মিলে যায়, I just pop out the index আর কি, or just print out the index number.
times we access elements from the list. So if we go in this direction, for example, we would need to access 13, 11, 12, and finally we discover 7. If we come from this end, we may discover 7, 6, 5, 4, and finally we may discover 7. So definitely coming from the left is better than coming from the right. But is that the best? That's what we're solving. Better than coming from the
No,
right.
wait, why is
11,
coming from
12,
the
and
right a
finally
bit
we
wrong?
discover 7. This direction, for example, we would need to access 13, 11, 12, and finally we discover 7. If we come from this end, we may discover
এখানে তিনটা এলিমেন্টের স্কোয়ার লাগতেছে, এখানে 4টা, but we don't know কোন জায়গায় আমার কি এলিমেন্টটা। So how would we know from which way to traverse?
7, 6, 5, 4, and finally we may discover 7. So definitely coming from the left is better than coming from the right. but is that the best?
Oh, so coming from the left is better than coming from the right. Yes.
That's what we're solving. Now, once we've defined the problem, and what you should do is you should try to write down the problem in your own words. And primarily, this is for you to make it clear to yourself. Either speak it out loud to the interviewer or write it down in your own words make it as short as long as possible so that you clearly understand what's in it. And then come up with the inputs and the outputs. So there are two inputs here. There's the input cards, which is a list of numbers sorted in decreasing order. And then the second input is a query, which is a number whose position in the array is to be determined. And there is one output, which is position, and the position is simply the position of query in the list of cards. For example, 7 is at position 3, counting from 0, of course. And as soon as you've written the input and output out, you can now write what is called the signature of our function, which is a string output out, counting from
0, 1, 2, 3.
0, of course. And as soon as you've written the input and output out, you can now write what is called the signature of our function, which is a structure of our function without any actual code inside
Exactly, key value.
it. So now we can call it def locate card with cards and query, and the single statement inside it called pass. Because a function in Python cannot have an empty body, you need to put in at least one statement. So you always put in the pass statement first because it doesn't do anything. There you go. So now we have framed our problem statement, locate card with cards and query, and the single statement inside it called pass. Because a function in Python cannot have an empty body, you need to put in at least one statement. So you always put in the pass statement first because it doesn't do anything. There you go. So now we have framed our problem in abstract terms, and now we have a function signature to work with. Now, a couple of tips here. This is something that interviewers specifically will look for, but also in coding assessments because your code is also shared with the company. So you may want to name your functions properly and think carefully about the signature. For example, here you should not call your function f1 or func1 or f or something like that. It's better to call it locate card because that's what it is doing. And the similar thing is true for variable names as well. Use descriptive variable names. One, because it's good coding practice, and second, because as you work on the problem, you may lose track of what a variable represents. For example, if you call this A and you call this B, now 20 minutes down the line, talking about the problem, writing different lines of code, you may forget what A and B represent. So please call them what they represent, even if it can get a little long. And finally, if you're unable to come up with a function signature, if you're unable to come up with a simple description, then discuss the problem with the interviewer if you're unsure how to frame it in abstract terms. So keep that in mind. And this is really the first how to, if you're unable to come up with a simple description, then discuss the problem with the interviewer if you're unsure how to frame it in abstract terms. So keep that in mind. And this is really the first and most important step, which is clarifying the problem statement and stating it clearly. Do not start coding before you have done this. Otherwise, you may get halfway into the code and realize that you have not understood the problem at all. So step 2. Now we will come up with some examples, some example inputs and outputs, and our goal will be to cover all the edge cases. So before we start implementing a function, we want to have some examples so that once we implement it, the first thing we'll want to know is it correct? And in general, the answer is no, because coding, especially when you're getting started, is hard because you have to think about many different scenarios. So, and especially interviews or coding assessments are also stressful situations. So you may not be able to focus and think about all the different things that you need to keep in mind. So simplest way to reduce the risk of going wrong is to use test cases. So here's one test case that we came up with. What we've done is we've taken the information that we had listed above in the inputs and outputs, and we've written it in as code. So now we have a variable called cards, which is a list of cards, a list of numbers. Then we have a query, which has the value 7. And then we have the output, which has the value 3. So the expected output from the function is 3. And once you have a test case, you can test your function at any point, anything you want to test. You can simply pass the input, for example, cards and query into the locate card function and get back a result. And you can see here right now, because there's nothing inside the function, the result you get back is none. But later you'll start getting back a proper result from your function. And what you can then do is you can compare the result with the output of the test case. So in this case, when we compare them, obviously the output is 3, the result is none, we get back false. Now, one thing we will do in this course to make testing easier, because we will be testing our algorithms again and again as we keep improving them, is that we will represent our test cases as dictionaries. So here, for example, this test case will be represented, or every test case will be represented as a dictionary containing 2 keys, input and output. And the input will contain 1 key for each argument to the function. So if your function arguments are called cards and query in the function signature, and that's why we wrote down a function signature first, so that we don't get confused here. So if your function arguments are called cards and query, then we can take one key called cards and put the value of cards there, one key called query, put the value of query there, and then in the output we simply put the output that we expect from the function. And now you can test this function like this. So how you might want to test it first is maybe by actually passing values like this. So you have test input cards and then test input query. But there's a trick here. Whenever you have a dictionary, so here we have a dictionary with 2 keys, and we want to pass, there's a trick here, cards and then test input query. But there's a trick here. Whenever you have a dictionary, so here we have a dictionary with 2 keys, and we want to pass these 2 keys as 2 arguments to a function. So we want to pass cards as the cards argument to the function locate card, and query as a query argument to locate cards. What you can do is you can simply put the dictionary itself and just write star star. Now, if you write star star, what Python does is it takes the keys from this dictionary, and the values are then used as arguments for parameters with these names. So there we are now calling locate card on test input, and we can compare it with test output. And you can see that we get back false. So that's one test case for us. But is that enough? Is that enough for you to now start writing code? Probably not, because out in the wild, your function should be able to handle any number or any set of valid inputs every the keys from this dictionary. And in the output, we simply put the output
Query is my key. Cards is my this.
that we expect from the function. And now you can test this function like this. So how you might want to test it first is maybe by actually passing values like this. So you have test input cards and then test input query. But there's a trick here. Whenever you have a dictionary, so here we have a dictionary with 2 keys, and we want to pass these 2 keys as 2 arguments to a function. So we want to pass cards as the cards argument to the function locate card, and query as a query argument to locate cards. What you can do is you can simply put the dictionary itself and just write star star. Now, if you write star star, what Python does is it takes the keys from this dictionary, and the values are then used as arguments for parameters with these names. So there we are now calling locate card on test input, and we can compare it with test output. And you can see that we get back false. So that's one test case for us. But is that enough? Is that enough for you to now start writing code? Probably not, because out in the wild, your function should be able to handle any number or any set of valid inputs that we pass into it. And here are some possible variations that we might encounter, and it really helps to list them. In fact, while I was writing these variations, I realized that there are many cases that I had not thought of. So even after coding for 12, 15 years almost, I still find it really useful to list out all the scenarios that we can find our input in. So the simplest scenario is that the query occurs somewhere in the middle on the list of cards. This is what you imagine when you read the question. This is what is called the general case. But then there are some special scenarios as well. What if the query is the first element in cards? And what if the query is the last element in cards? What if the list cards contains just one element, which is the query itself? Or, and this is something that I had not thought of, what if the list cards does not even contain the number query? What if Alice is bluffing? So what should be Bob's strategy then to figure out that the number does not exist? What if the list of cards is empty? And what if the list contains repeating numbers? This is again another interesting thing that may not come to mind because we said a list of numbers and we did not specify that the numbers are unique. So the list can contain repeating numbers. And finally, what if the number, the query itself occurs in more than one position in cards? So those are 8 queries may not come to mind because we said a list of numbers, and we did not specify that the cases that I could in a coding interview, or just see if you can think of any more variations. And it's likely that when you first heard the problem, you did not think of all these cases because you often tend to just focus on one generic case. It's hard to hold too many cases in mind, and that's why it helps to list them down, actually write them down. In a coding interview or in a coding assessment or an interview, you may want to put this in comments. If you have a coding page, you can just create a comments and list out all the test cases. And some of these, especially things like the empty array or query not occurring in cards, are called edge cases because they represent rare or extreme examples. And while edge cases may not occur very frequently, your program should be able to handle edge cases. Otherwise, they may fail in unexpected ways, or somebody with malintentions can use the edge cases to hack your software. So let's create some more test cases for the variations that we've listed, and we'll store all our test cases in a list for easier testing. So here we are creating a list called tests, and this time we will create all our test cases in the format that we discussed, which is a dictionary format, and we will keep appending them to our list. Now, if you do not understand lists and dictionaries and appending, then you can go back and review some of the basic material on Python, which is linked at the top of this notebook. So first we take the one test case that we already have, we put that, and we take maybe one more example of the query occurring somewhere in the middle. So here you can see this is the cards list, and that the query 1 occurs somewhere in the middle, although it's closer to one end. Then here's one case where the query is the first element. Here you can see this is the cards list, and that the query 1 occurs somewhere in the middle, although it's closer to one end. Then here's one case where the query is the first element, 4, and the output, obviously the output expected is 0. Here's one case where the query is the last element, minus 127. And this is another thing, the numbers could be negative as well, something you may want to keep in mind. Here's another one, where cards contains just one element, the query itself. Now, the problem does not state what to do if the list cards does not contain the number query. And you may often face these questions where it may not be clear what to do in a certain situation, or if a certain situation can occur. And when you have questions like this is a process you should follow. Step 1, read the problem statement carefully, or ask the interviewer to repeat the question. So read the problem statement carefully, and you will often find hints, and sometimes these hints are just single words somewhere. Often you will also find some examples provided with the problem. You will also find, if you scroll down to the bottom, you will find some conditions. You will find limits on what the numbers can be, whether they can be integers or can be decimals, whether they can be negative or positive. So it's important to read the problem carefully before you start coding and look through the examples. And then ask the interviewer, or maybe post a question on the platform for a clarification. Often it happens that interviewers, because they take so many interviews, they may forget to specify a certain detail, or they might expect you to ask the question because you should not be coding with an insufficient requirement. So to clarify the specifications of the problem is very important. So if you have any doubt, ask the interviewer. Even if you are somewhat sure about it but just want to verify, it's a good idea to ask. Then finally, if you are done with all of these and you still do not have a solution, then you just make a reasonable assumption, state it, and move forward. So we will assume that our function will return -1 in case cards does not contain query. So if cards does not contain query, then we expect the function to return -1. Now here's one other case where the cards array is empty, and obviously then it does not contain the query as well. And finally, there's one last case, which is the number itself can repeat in cards. Numbers can repeat in cards, and then the query itself can repeat in cards. So here, the query does not repeat, 3 does not repeat, but the numbers in the cards array do repeat. And the last case is when the query itself repeats. So you can see here in cards, the query occurs many times. Once again, it is not specified what to do here, and sometimes it may be okay. Sometimes the problem statement may just say that return any one position, but more likely than not, what you will want to do is you may want to make it more determinate.
Wait, আসতেছে।
deterministic, and that will also make it easy for you to test the function. So what we can can say, we can impose this additional restriction that we will expect our function to return the first occurrence of query. And that will make it easier for us to test, so that when we're testing our problem, we know that if we're getting a failure, it's not because of multiple possible answers, but it's because of some issue in our code, right? So you want to get good feedback from failures, and that's why you want your tests to be deterministic. So here is the final test. And now we can see the full list of test cases. So now we can see the list of test cases here. So you have about 8 or 10 test cases here. You may not need to create this many test cases in an interview or a coding assessment, depending on how much time you have. But you should create at least a few, at least cover the 3 or 4 edge cases. A good number to aim for would be 5. And this will not only help you in the coding interview, help you solve the problem, this will also be appreciated by the interviewer because it shows that you're thinking about the problem. So definitely take a minute or two. We've spent 10-15 minutes talking about this, but once you start applying this technique over and over, you will see that you will start creating test cases in seconds. So as soon as you read the problem and you state the problem, find the input format, find the output format, write a function signature, and write the test. Then you will start working on test. The ideas will automatically start coming to you. And within maybe 2 or 3 minutes, you will be done with both of these steps. So great, we now have a fairly exhaustive set of test cases, and creating test cases beforehand allows you to identify different variations and edge cases. And sometimes it may happen that you may have no clue how to work on the problem. You may feel completely confused. But if you simply start writing multiple test cases and start looking at them, like literally just staring at the test cases, the question and the answer, the solution will reveal itself to you. So don't underestimate the power of writing things down. And don't stress out if you can't come up with an exhaustive list of test cases, because this takes time. It's a skill that you cultivate with time. So what you can do is you can list out maybe the test cases that come to your mind right now and put them in a single place and keep coming back. Whenever a new test case comes to mind, while coding or while discussing or while analyzing, you can just come back to the same place and write down the test case. The important thing is that you have a single place where you're listing all test cases. So we've written our test cases now. And now we can come up with a correct solution. And how do you come up with the correct solution? Not by writing code, but by first stating it in plain English. So your first goal, and by correct, we do not mean the best or the most efficient solution. First, we want to solve the problem. We want to figure out where the particular number lies in the list and not to minimize, because that's solving 2 problems at once and sometimes that can get tricky. So first aim for correctness, then aim for efficiency. And the simplest or the most obvious solution, which almost always exists and is almost always very easy to see, involves checking all the possible answers. And this is also called the brute force solution. So in this problem, coming up with the brute force solution is quite easy. Bob can simply turn over the cards in order one by one till he finds the card with the given number on it. So this is how it might work if we want to implement it in code. And this is where writing it in your own words becomes important. So we create a variable called position inside a function with the value 0. Then we check that the number at the index position in the card list equals query or not. Now, if it does, since we start starting from the beginning, if it does, then position is the answer and we can return it from our function. But if it doesn't, then we simply increment the value of position by 1 and then we repeat the steps. So we go back to step 2 and when we check whether the number at the index position in cards equals query. And once again, if it does, we return position. If not, we increment the position once again and repeat. And we repeat that till we reach the last position. And if the number was not found, we return -1. So it's a simple 4-5 step description. Doesn't take very long. You can either say it out loud to the interviewer. They will also appreciate it, that they will know. You may know that you know the brute force solution, and you may not say it because it seems too simple or obvious. But the interviewer doesn't know that. So it's important to state the brute force solution. You may say that the brute force solution is fairly straightforward and it goes like this: steps 1, 2, 3, 4. It just take 30 seconds, but at the very least, it informs the interviewer that you're able to think of some solution. And it happens very often. I've seen it in interviews where 30-40 minutes have passed out of 45 minutes and not a single solution has been proposed so far, even though many lines of code have been written. So it's important to state your solution. And if you state your solution, the interviewer will also help you and correct you as you go forward, right? So it is a collaborative experience. It is a discussion. So use that. And if you are in a coding assessment, you may just want to write out a few comments. And what we've implemented here is, congratulations, is just our first algorithm. And an algorithm is simply a list of statements, a list of steps that can be converted into code and executed by a computer on different sets of inputs. So this particular algorithm is called linear search because it involves searching through a list in a linear fashion, element by element. So now we're ready to implement the solution. And just a quick tip, as I've already said, always try to express the algorithm in your own words. And it can be as brief or as detailed as you like. And don't underestimate the power of writing. Writing can be a great tool for thinking. It's likely that you will find that some part of the solution is difficult for you to express. And that simply suggests that you are probably unable to think about that part clearly. So the more clearly you are able to express your thoughts, the easier it will be for you to turn it into code. And you will not have to come up with a strategy while you're writing the code. So you can focus on coding and focus on avoiding errors. And that part clearly. So the more clearly you are able to express your thoughts, the easier it will be for you to turn it into code. And you will not have to come up with a strategy while you're writing the code. So you can focus on coding and focus on avoiding errors. And that brings us to the next step. Implement the solution and then test it using the example input. So now you can see how everything comes together. We've already know what the function signature looks like, what the inputs look like. We already have some test cases, and through the test cases, we've also identified what are the different edge cases we need to handle. And we've already written out a description, a rough description of what the algorithm looks like. And in fact, what you can do is you can simply write out comments within your function as the English description, and then you simply need to fill out code for those comments. So for instance, here are the 5 steps that we had just written down. Create a variable, position with the value 0, set up a loop, check if the element matches the query. If yes, the answer is found. If not, increment the position and then go back and then check. If you position with the value 0, set up a loop, check if the element matches the query. If yes, the position with the value 0, set up a loop, check if the element matches the query. If yes, Yes, the answer is found. If not, increment the position and then go back and then check if we've reached the end of the array. If we have, then we return -1. So if not, increment the position and then go back and then check if we've reached the end of the array. Increment the position and then go back and then check if we've reached the end of the array. If we have, then we return -1. So, and the code now is pretty straightforward. Now we create the position variable 0. We set while true. So while true kicks off a loop, and we just want to first set up a loop, and then we can break out of it when we need to. Then we check if the element at the value position matches the query. If it does, we return the position. If it doesn't, so if it doesn't, then this we come to this part. If it does, then the function exits and none of this code gets executed. But if it doesn't, then we increment the position and then we check if we have reached the end. Now, if we have reached the end, obviously we don't want to continue. So we can simply return -1 and exit the loop and exit the function itself. But if we have not reached the end, then we go back to the top of the loop and now position starts out with value 1. So we check value 0, 1, 2, 3, so on up to the end of the array. Simple enough. Great. So now we have our first function. And let's test our function with the first test case. So here's our test case once again. And we can simply call locate card with the test input and the cards in the query. And this is the result we get. And you can already see that. And we can simply call locate. So here's our test case once again. And we can simply call locate card with the test input and the cards in the query. And this is the result we get. And you can already see that the result matches the output. And that's why when we compare them, we get the value true. So yeah, the results match the output and locate card 2, 3, so on, our first function. And let's test, and we can simply call locate card with the test input and the cards in the query. And this is the result we get. You should be doing very often. In this course, we have put together a small function for you because this is value true. So yeah, the results match the output. And because this is something that you should be doing very often, in this course, we have put together a small function for you within the Jovian Python library. So the Jovian platform also offers a Python helper library that contains some utility functions. So we've put together a small function for you called evaluate test case, and you can write it on your own as well, but you can use this library version. So let's install the library. We will install the Jovian library using pip install Jovian -- upgrade. And then from jovian.python DSA, so Jovian is the name of the library, and then inside the Jovian library, since we have many courses, the Python DSA course, the utilities for this course are present inside the Python DSA module. From that module, we import the function evaluate test case. And finally, we can call evaluate test case, and then we can give it the function that we want to test. So we want to test the locate card function and the test case. The test case needs to be defined in this format. So all it is going to do is it is going to pick out the input, pass it into the function, get the output, compare that output with the expected output, and also print some information for you to see. So here's what it does. It prints out the input. It prints out the expected output. It prints out the actual output. It prints the execution time. And this is something that will become important later, and it tells you whether the test has passed or not. So it's nice to have this, because so we don't have to look through the output and input and compare them, especially when you're in a situation where you need to think fast. It's helpful to create a small function that can just print pass or fail for a test case. So now, while it may seem like we have a working solution because our test case has passed, we can't be sure about it until we test the function with all the test cases. So for doing that, we can use the evaluate test cases function. So just as you have evaluate test case, you have evaluate test cases, also part of the Jovian library. And you can call evaluate test cases with the same function locate card, and this time pass it a list of test cases. Each of the test cases is a dictionary. Again, you don't have to use this function. You can simply put things into a loop. So you can always just do for test in tests, and then simply call evaluate test with locate card and test. Or you can even just directly call locate card with the test inputs and the test out, and compare the output with the test output, right? So you can do this as well, and you can simply print that. So here's a simple way to do this, what we are doing here. But what we'll do is we'll use the evaluate test cases function because it prints out a lot of useful information for us. So now you can see that it prints out case by case. Now test case 0, we have input, expected output, actual output. The test case has passed. That's what we saw. In fact, it's the same test we just did. Test case 1 passes as well. Test case 2, we'll use test cases until we test the function with all the test cases. So for doing that, we can use the evaluate test cases function locate card, and this time pass it a list of test cases and test. Or you can even just directly call inputs. This here cases prints out case by case. Test cases passed. That's what we saw. In fact, it's the same test we just did. Test case 1 passes as well. Test case 2 passes. Test case 3, 4, 5, 6. Okay, all of them are fine. Okay. Test case 6 seems to have caused an error. So here is the error. It says list index out of range. So that's okay. It's perfectly all right for your functions to encounter an error. So the first thing, the most important thing is not to panic. In fact, it's a good thing that we know exactly where the function is failing. If you look back here, you can see what the issue is, and then we'll see how to fix the error. But one good strategy to approach this is to keep in mind that there will always be bugs in your code, and approach writing code not with the assumption that your code will be correct, but go with the default assumption that your code will be wrong, that there will be issues. What that lets you do is, one, you do not feel demotivated or you do not panic when you see an error. And second, you then tend to be a little more careful while actually writing the code. So the way you should be writing code is, every time you write a line of code, you should be asking yourself, how can this line of code go wrong? Or in this particular case, how can cards position equals query in an if statement go wrong and throw an error? And let's look at it. One easy way to check this is to add what is called a logging, or what is called printing the information inside a function. So we'll just rewrite our function. In our locate card function, we will put in cards and we will put in query, the exact same function that we have. We'll set the position. But before we create the value, we'll simply print the cards in the query. So just for our information, just so that we can see what the function is working through, we can get some visibility into the function, we print out cards and query, and then while true, so this is the same loop. At the beginning of the loop, we will print out the position that we are tracking. Okay, so let's do that. We've simply added some print statements, and this print statement will give us an insight into the inner working of the function. Now, if you do not put in a print statement, then you will have to work it out yourself by reading the code and executing it in your head. It's always easier to just print all the information and then print it nicely. Just say cards and query. We could also have done this without saying cards here, but then that would make it a little harder to read. Then that would be more cognitive overload, apart from already dealing with the stress of solving